Okay, two more examples of using separation of variables. If you have dy dx equals 4x to the third plus sine x, then step one is still separate. I'm going to take this dx and move it to the right. So dy equals 4x cubed plus sine x dx. Step two, take the antiderivative of both sides. The antiderivative, the integral of the derivative of y is just y itself. Now I'm going to use the power rule. You add 1, so that makes this x to the fourth. Divide by your new exponent. 4 over 4 is 1. Then I know the derivative of cosine gave me something with sine in it, so my logic works as follows. The derivative of cosine is negative sine, so the integral of sine is negative cosine x plus c. Then you want to take the derivative to check. dy dx equals 4x cubed plus sine x, and that works out. So this is a solution to my differential equation using separation of variables. One more. If you start with dy dx equals x over y, and we know that y is greater than 0. Okay, I'm going to ignore this for now and actually just start the process of separation of variables and integrating. So I'm going to take this dx, move it to the right, take the y, move it to the left. Both of those are done with multiplication. So I have y dy equals x dx. Take the antiderivative, the integral of both sides. Now I'm going to undo the power rule. This is a y to the first right now. It's going to become a y squared, raise the power by 1, divide by your new power. So that's a y squared over 2, or you can put the 1/2 out front. Equals, raise the power by 1, it becomes an x squared, divide by your new exponent, so divide by 2 or multiply by 1/2, plus c. Now this is nice, but it's not actually solved for y yet. Remember, your goal for differential equations is to get y equals. So I'm going to get this y by itself. Step 1 is multiply by 2. So I have y squared equals x squared, and then some people would write 2c, but 2 times a constant is just a constant. So until I've actually solved for what that c is, it doesn't really matter if I write 2c or c. The next step would be to take the square root. So I'm going to say y equals, and remember when you take a square root, it's plus or minus the square root of the whole side. So x squared plus c inside of the square root. Now, plus or minus, that's where this comes into play. We said y is greater than 0, so I'm going to choose the positive version. So my y equals the square root of x squared plus c. If it had said y is less than 0, my solution would have been y equals the negative square root of x squared plus c.